right, welcome back to our discussion about solving trigonometric equations. And in this video, we are going to talk about the techniques that we can use to solve trig equations where the argument of the trig function is a little more complicated than just x. We might have multiple angles, or we might have something even more complicated than that. So we're going to use this strategy when we have a trig function and whatever the argument is just greater than a single variable, okay? So what we're going to do is we're going to substitute u in for that complicated argument. We're going to simplify it a little bit, okay? And then after we've done that, we're going to solve for u. And then whatever we get for u, we are going to back substitute that complicated argument back in, and then we'll go ahead and solve for the variable that we originally had. So in this case, we have this argument that is more than just a single variable. So this 2x makes it a little more complicated. Okay, so what we're going to do is we're going to substitute that out. We're going to let u equal 2x, and so we're going to just make this argument into u. And now this is easy, okay? So now I'm just going to say, all right, well then what is u? We will solve for u by saying, okay, what angles on the unit circle have a cosine of the square root of 2 over 2? Okay, so which angles have an x value of square root of 2 over 2? And so that's going to be pi over 4 and 7 pi over 4. Because we are solving for a general solution, we're going to include that plus 2 pi n part in our solution there. Okay, so we've substituted the u in, we've solved for u. Now what we're going to do is we're going to back substitute the complicated argument. We took out this 2x and substituted in the u. Now we're going to put it back in. Okay, so where we see u, we're going to put that 2x back in. Okay, and now we are going to solve for x by isolating that variable. So we're going to multiply the left and the right hand side of both of these equations by 1/2, and then simplify. We'll get x is equal to pi over 8 plus half of 2 pi n is pi n. Okay, and here x is equal to 7 pi over 8 plus pi n. So it's not too bad, but it's a little more complicated than our first strategy. Okay, so let's try this second one. All right, so let's try this next one. The sine of 4x is equal to negative the square root of 3 over 2. So we're going to substitute out this 4x and substitute in a u where we see this 4x. Okay, so we're just going to replace the 4x with u. And so we're going to say the sine of u is equal to negative rad 3 over 2. Okay? Which angles have a sine of negative rad 3 over 2? So which angles have a y value, since we're looking for sine, of negative rad 3 over 2? Well, I think you'll find those in the third and fourth quadrants. And you should say that it's going to be 4 pi over 3 and 5 pi over 3. So again, we're going to use the plus 2 pi n since we're looking for our general solution. Okay, so we've solved for u. Now we're going to back substitute, okay? And so we are going to take this 4x and sub it back in for u. We took it out, right? We took the 4x out, made it u, and now we're putting it back in right here, and we're back substituting the 4x back in for u. Okay, so now we're going to isolate x by multiplying both sides through by 1/4. So let's do that. And when we end up with our solution, right, this will isolate x on the left-hand side. This 1/4 of 4 pi over 3 will end up being pi over 3. And this will end up being 2 pi n over 4, or pi over 2n. And then on the right-hand equation, we've got x is equal to 5 pi over 12 plus pi n over 2. So these two examples, we're going to use that same strategy, but we are also going to use some reciprocal strategy as well. And we did that once in our first video where we're doing some very simple trig equations. When you see our reciprocal functions, secant, cosecant, or cotangent, we will want to rewrite those as sine, cosine, or tangent because they're just easier to deal with. So let's go ahead and first sub out our argument. So instead of secant of 3x divided by 2 is equal to negative 2, we'll make that secant of u is equal to negative 2. Now let's reciprocate both sides. So 1 over the secant of u will be the cosine of u, and 1 over negative 2 will be negative 1/2. Okay, now that looks much better, and I know what to do with it, right? I can think about what is going on the unit circle, or which angles on the unit circle have an x value of negative 1/2. And you would find those at 2 pi over 3 and 4 pi over 3. And since we're doing general solutions, we would add the plus 2 pi n on both of those. Now let's go back and back substitute our original argument. We substituted out 3x over 2 for u, so now we need to substitute it back in. So 3x over 2 is equal to 2 pi over 3 plus 2 pi n, and 3x over 2 is equal to 4 pi over 3 plus 2 pi n. So now we would do the algebra we need to isolate our variable, our x. For both of our equations, on both sides of the equations, we're going to multiply by 2/3, the reciprocal of 3/2. So let's go ahead and do that. Notice that 2/3 times 3/2, that's going to cancel this out. I'm just going to get x on the left-hand side of both of these equations. And then I would just multiply this 2/3 straight across. I would distribute it out. And I'd end up with 4 pi over 9 plus 4 pi n over 3. And then on this right-hand equation, I would end up with 8 pi over 9 plus 4 pi n over 3. And those would be my two general solutions to this equation. So for this one, this cotangent, we're going to do it very similarly to this one. First, we'll substitute out our argument, and so we'll make that cotangent of u is equal to negative square root of 3. And now we will reciprocate both sides. So 1 over the cotangent of u will be tangent of u. And 1 over negative square root of 3 will be negative square root of 3 over 3. So I've got tangent of u is equal to negative square root of 3 over 3. Where on the unit circle are there angles that have a tangent of negative square root of 3 over 3? You will find those at 5 pi over 6 and 11 pi over 6. And for that general solution, we'll add a plus pi n for the tangent. All right, back substitute. Put back in the argument that we took out. The argument that we took out was 3x divided by 2, so that's going to go back in every time we see a u. So 3x over 2 is equal to 5 pi over 6 plus pi n. And 3x over 2 is equal to 11 pi over 6 plus pi n. All right, let's get rid of the coefficient to x. So we'll multiply both sides of both equations by 2/3. 2/3 times 3x divided by 2 will give us an x on the left-hand side of this first equation. And then when we multiply this 2/3 times 5 pi over 6 plus pi n, we'll get 10 pi over 18, which will simplify to 5 pi over 9, plus 2 pi n over 3. Okay, and this right-hand equation is going to be similar. The only thing that will be different is this first piece, 2/3 times 11 pi over 6. That will be 22 pi over 18, which will simplify to 11 pi over 9. Now let's examine, with tangent, we often have redundancies, right? So if I think about 5 pi over 9 plus 2 pi over 3, Let me think about that. 2 pi over 3 is the same as 6 pi over 9. So if I add 5 pi over 9 and 6 pi over 9, I do get 11 pi over 9. So that is a bit redundant. We don't actually need it, but it's not wrong to write it. We have a couple more to look at. In both of these cases, we end up with some arguments that are actually quite a bit more complicated because not only are they multiple angles, but there's an adder in there. But we handle it exactly the same way. We substitute out that complicated argument and make it just u, and then we solve for u by thinking about which angles on the unit circle have y coordinates, because we're looking for sine, of 1/2. And that would be at pi over 6 and 5 pi over 6. So pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Now let's back substitute the argument. Here's that complicated argument, 2x plus pi over 6, and we're going to replace the u's in both of these equations with that complicated argument. And now we're going to go ahead and isolate x. So here we would want to subtract pi over 6 first on both sides of both equations. So when I subtract it on this first equation, these two are just going to cancel out, and I'll end up with 2x is equal to 2 pi n. I'll subtract pi over 6 from 5 pi over 6 and get 4 pi over 6. Now, of course, we can simplify that 4 pi over 6. We'll do that when we divide through the 2. If I divide through a 2 everywhere, or multiply by 1/2, we'll end up with x is equal to 0 plus pi n, or you could just call it pi n. And here, when I multiply this by 1/2, we would end up with pi over 3 plus pi n. Now, once you know the trick of how to solve these, they're not so bad, but they do look intimidating until you know this strategy. Let's do this last one. The cosine of 2x minus pi over 4 is equal to the square root of 2 over 2. Substitute out that complicated argument and make that whole thing a u. Find the angles on the unit circle that have an x coordinate of the square root of 2 over 2. That's going to be pi over 4 and 7 pi over 4. And since it's a cosine, we're going to add a 2 pi n. Back substitute that complicated argument and then solve for x. Add a pi over 4 to both sides of both equations. Okay, so when I add a pi over 4 here, I'll have 2 pi over 4. And when I add a pi over 4 here, I'll have 8 pi over 4. Okay, and now divide through by 2 or multiply through by 1/2. And we end up with x is equal to pi over 4 plus pi n, and x is equal to pi plus pi n. All right, that takes care of this strategy. The next strategy we're going to talk about is how do we solve trig equations when they're in quadratic form. That's a great one, and I will see you then.